So here the case number 2 is of, we have to prove A intersection B is equals to B minus A dash. But here in order to prove that A intersection B is equals to B minus A dash, we have to prove the two conditions, that is left hand side must be the subset of right hand side and this right hand side must be the subset of left hand side. So here in order to prove the condition, that is A intersection B is equals to B minus A dash. So first of all we have to prove the two conditions. So here the two conditions are of, the first one is left hand side, that is A intersection B must be the subset to right hand side B minus A dash, and the second condition is, so here right hand side, that is B minus A dash must be the subset to the left hand side, that is A intersection B. But here in these two cases I want to first of all prove the first one as A intersection B the subset of B minus A dash. So here I want to prove it by means of element wise. So here the element wise proof is of, we have to consider one element which belongs to the left hand side. So here let us consider the element as, let x be the element which belongs to A intersection B. Then now that implies, so here x belongs to first set, that is A, intersection indicates and, so here the symbolic notation is of inverted V, and x also belongs to the second set, that is B, x belongs to B. Then as per the definition of the intersection of two sets, according to the commutative property upon intersection of the two sets, we can write it as x belongs to A and x belongs to B can be written as x belongs to B and x belongs to A. So here the reason is of commutative property. That is A intersection B is equals to B intersection A. Then now the next logical step will be of, so that implies x belongs to B and x, so here belonging to A is there, instead of belongs to I am going to write it as does not belongs to, then automatically instead of A I have to write its complement. So here x belongs to A can also be written as x does not belongs to A complement. Then now the next logical step will be of, so here that implies x belongs to, because here x is present in B and x does not belongs to this set, that is A complement. So here we can write it as, so x belongs to, since it is not present in A complement, so here A complement must be subtracted from this set, that is B. So here in this manner, so here we got, so here x belongs to B minus A dash. Then now, so here then we have left hand side is of x belongs to A intersection B implies the right hand side is of x belongs to B minus A dash. Then now here x is an element which is present in the LHS, that is A intersection B, and the same element, that is x is also belonging to the second set, that is the right hand side set B minus A dash. That is the elements which are present in the LHS are also the elements of the right hand side set, therefore LHS must be the left hand side set must be the subset of the right hand side set. So here therefore we can write it as, so left hand side set is of A intersection B will be the subset to the right hand side set, that is B minus A dash. So in this manner we have proved the first condition from the first case, which is nothing but, so here A intersection B is a subset of B minus A dash. A intersection B is the subset of B minus A dash. We are going to consider this step as the equation number 1 or the condition number 1. Then now we have to prove the second case, that is B minus A dash must be the subset of A intersection B. Then now the second case, so in the second case we have to prove B minus A dash as the subset of A intersection B. So this is our second case, B minus A dash as the subset of A intersection B. But here since we are going to prove by means of the element wise, we have to suppose one element which belongs to the left hand side set. Let x be an element which belongs to the left hand side, that is B minus A dash. Then now that implies x belongs to B. since a dash is subtracted, so x does not belongs to this a dash. So here x belongs to this first set, that is b, and so here x, since a dash is removed, so here x does not belongs to this a dash. Then now the next logical step will be of x belongs to b and x here does not belongs to a complement. If I write instead of does not belongs to as belongs to, then now instead of a complement I have write only a. Then now here the next logical step will be of, as per the definition of the intersection of two sets, we can write it as x belongs to b and x belongs to a can be written as x belongs to a and x belongs to b. So here we got this logical step by means of the definition of the intersection of two sets as the commutative property. So here the commutative property holds good by the definition and as well as the commutative property. So here the commutative property is of a intersection b is equals to b intersection a. So here I have utilized this condition. So based upon the definition and as well as the commutative property, instead of b intersection a, I wrote here a intersection b. Then now the next logical step will be of, that implies x is present in a and as well as x is present in b. So it can be written as x belongs to a and b can be written as intersection b. Then now, so then we have the left hand side is of x belongs to b minus a dash. Then now that implies, so here the right hand side is of x belongs to a intersection b. So from this it is clear that x is an element which belongs to this set, that is b minus a dash, and the same element x is also belonging to the a intersection b set. The elements which are present in the left hand side set are also the elements of the right hand side set, therefore the left hand side set must be the subset of the right hand side. So in this manner we got b minus a dash is the subset of, so here a intersection b. So here let us consider this as the equation number 2 or the condition number 2. So here from two conditions, that is from equations 1 and as well as 2, the first equation is of a intersection b, the subset of b minus a dash. Then the second one has b minus a dash, the subset of a intersection b. So here this has the first equation and this one has the second equation. From this it is clear that, so LHS a intersection b is the subset of b minus a dash and that b minus a dash is the subset of a intersection b, that is LHS is the subset of RHS and RHS is the subset of LHS. Hence LHS and RHS must be equal. So here therefore we can write it as a intersection b is equals to b minus a dash. So here we have proved two conditions, that is first one as a intersection b equals to a minus b dash, and in the second case we proved a intersection b equals to b minus a dash. So from these two conditions, so here from the conditions, say a intersection b is equals to a minus b dash, and the second condition as a intersection b is equals to b minus a dash. It is clear that the left hand sides are equal, therefore the right hand sides also must be equated. So here, say on the whole we can write it as, therefore a intersection b is equals to a minus b dash, then that is equals to b minus a dash. So here in this manner all the three conditions are equal. Since LHS are equal, therefore the right hand sides must be equated. So when a minus b dash is equals to b minus a dash, then both are equated to what is here a intersection b. So in this manner say all the three are equal, that is a intersection b will be equals to a minus b dash, then that is equals to b minus a dash.